Okay, in this video, we're going to be solving the Tic Tac Toe project. And here we're going to be implementing the game logic for a Tic Tac Toe game. And we have some code in the editor to start out with. So I'm going to just pull this up and we'll start by looking at the code. So we have these type definitions and we also have two classes which have been created. So we have a game player class and a game class. So the idea here is that the game class, which is going to implement this tic-tac-toe game interface, is going to be responsible for actually executing the logic for the game. And then the player class, this game player class here, which implements this tic-tac-toe player interface, is going to represent one of the players in the game. And then we can look at these smaller types at the top, and we can see that a player is either a human or a machine. And then we have these other game types. So we have a tile, a board, and a game result. So if you look at the board type is just a two-dimensional array of these tiles. And a tile can either be a player, which again is a machine or a human, or null. So this is just a way to represent a tic-tac-toe game board using a programming language. So basically using a two-dimensional array of values, which can either represent a player having played on that tile or the tile being empty and no one having played on it yet. So for this project, there's a few methods which need to be implemented for this game to work correctly. And we're looking at them here. They're highlighted with these comments. So the play method for the game player class is one of them. And in the game class, we have to implement the checkerboard method and the play game method. So let's start with the play method for the game player class. So this method will accept a board as an argument, and it should return that same board after making a play on the board. So in this method, you can actually implement some logic to choose where you should play on the game board. And so here, just to keep things very simple, we will implement some very kind of naive logic, and we will just play on the first unoccupied tile. So what we can do is we can just take this board and we can start iterating through the board, and we can visit every location in the board. And so before I implement this, actually, let's jump down to the very bottom, and I'm going to write some additional helper code, which is going to help us debug the solution as we're working on it. So what I'm going to do is I'm going to create a new board, and I'll just manually create a board here. And so this is going to help us see what the board actually looks like. So initially the board will look like this, where it's just a two-dimensional array and it's full of null values because initially no one has played. And so you can see how this kind of looks visually like a tic-tac-toe board. And then I'm going to actually create a new player. So I'll go ahead and create a new player, even though we haven't actually fully implemented that method yet. So I can say new game player, and I'll just say this is a human player. And so you'll see that the game player class has a constructor which accepts a player argument. And so when you create a new game player, you can specify if it should be a human or a machine player. Okay, so now we have a player here, and we have a board, and our play method takes a board as an argument, and then it returns that board. So what we can do is we can just say player.play. We can go ahead and call this method, and then what I want to, and we need to pass in the board. And what I want to do is I want to add some kind of logging so we can actually print out the current values in the board so we can see them over here in the console. And so you'll see that there is this method print board, which is on our game class. But right now we're just working on this player, so I won't touch the game class yet. Instead, I'll just create a similar method out here. I'll just call it log. Actually, we can just basically copy this method here and just pull it out like this, and then you can just use the exact same method, but this is now going to take a board argument and we're going to reference that directly. And so we're just going to iterate through each row in the board and print out what that row is. And then to make this a little bit more clear, we will just say console.log board like this, and then we'll just do one more console.log here to print an empty line, so it's more clear. The gaps between the boards that we're printing out are more clear. So that looks good. And then one more thing, let's come up here and let's just return the same board with no implementation yet. Okay, so let's just go ahead and run this code, and we'll see. Okay, so we need to actually call print board with the board here like this. So we can call run, and now you'll see here's our board, and it looks just like it does here because we haven't actually played anywhere yet. So this is just some helper code, helper debugging code. And this is just to help us kind of get started and to visualize the changes that we're making and see if we're getting the results that we're looking for. Okay, so now we want to jump back to where we were before, and we want to go ahead and implement this play method. And so, like I was saying earlier, what we want to do is we want to just start with the first tile, and we want to just iterate through the board and visit every tile in the board. And as soon as we find an unoccupied tile, we want to go ahead and play on that tile. So what this would look like is we would just say for let I equals 0, I is less than the board.length, and then we're going to increment I, and then we need to create another for loop. So this is going to go through and visit every row in the board, and then for each row we need to go through and visit each column position in that row. So we can say for let j equals 0, j is less than the length of this row, and we're going to increment j by 1. So then we can say at each position we have a tile, and that's going to be board of I and j. And so if we get to a tile which is null, because remember a tile can be a player or null, so as soon as we find a tile which is null, we want to update that tile to be the player. And which player are we talking about? Well, we're talking about the player for this player class, and that information is stored in this player instance variable. So we can just say this.player here. So this is going to set the current value of this tile that we're at to the value of this player. And as soon as we've done that, then we've finished playing and we're done. So we can just return the board, because we want to break out of these loops and we don't want to keep going through and finding other null tiles and also playing on those, because you only get to play on one tile per turn. Okay, so this is again like super simple logic, which it should basically get the job done for us to complete this project. But I would encourage you to think about more creative ways or more strategic ways that you could try to design the logic here for playing on the game board. Okay, so now let's come back here, and we are calling the method here. So let's just go ahead and run the code again. And now you'll see that we actually have humans showing up in this first tile. Okay, that's good. That's what we're looking for. And so let's go ahead and do this a few more times. Run the code again, and you'll see that now we have human being played once, and then in the first 2 tiles, and then in the first 3 tiles. So it looks like this is going through correctly and playing on the first unoccupied tile that it finds. Okay, so this is looking pretty good. This is the implementation for the game player class. And now we need to come down and check out this game class here. So for the game class, we need to implement 2 methods. One is this checkboard method, and this is the method which is going to essentially determine if someone has won the game or if there's a tie. And so it's going to return a game result or null. And the game result is either a player or a tie. Okay, and the other method is this playGame method. So this playGame method is going to use the checkerboard method, and the playGame method, the logic for that will basically be to play the game, and this method accepts two arguments, a human player and a machine player. So this method will basically be responsible for having each of these players play back and forth and take turns until there's a winner or there's a tie. And so to know if the game has finished, this method is going to use the checkerboard method. So we'll start here with this implementation. And so for the checkerboard method, there's basically three types of ways you can win a tic-tac-toe game. One is by getting a row of all of your tiles full. So if you're playing either X's or O's or whichever player you're playing as, by getting 3 in a row. So we need to check all the rows. And then the second way would be getting a column. So we need to check all the columns. And the final way would be getting a diagonal. So we need to check both diagonals. Okay, and so again, we can just go through and implement this logic in a pretty straightforward way. So for the rows, we can just say, we can have another for loop, and we can say for const row of board, and we receive the board in the argument here. So we can just iterate through each row, and we can just check and see if the row contains all of the same value. So we can say, we can just check this manually, and we can say if the current row at position 0 is not equal to null, because we want to check and make sure that it's actually populated by a human or machine player. So if it's not equal to null, and the row at 0 is equal to the row at position 1, and the row at position 1 is equal to the row at position 2. If this condition is true, that means that effectively for this row, which looks like, we'll just say like this, so this row here would satisfy this condition, where the first element is not equal to null, and the first element is equal to the second element, and the second element is equal to the third element. So if this is true, then we have 3 in a row here. And so then we can just return whatever element we have in the first position. Really, we can return any of these elements, but we can just use the first position because we have to return one of them. So this will effectively check this row, and as soon as we find 3 elements which are the same, we will just return whatever that element is. And this will go through and check all 3 rows in the board. And if we don't meet this condition, then nothing will happen, and then we will get all the way through this for loop and we'll end up here. And then we just want to do the same thing for the columns. So to check the columns, we can say for let I equal 0, and we need to actually track the index here. Say until we get to the end of the board, and we're going to increment I. And so now we want to apply the same logic, but for each position in the columns as we move across the board. So we can say if the board at position I, so this is going to give us our current column. So if the first tile is not equal to null, and then we have our same logic from before, if the column at position 0, I'll just copy this, if this is equal to the column at position 1, and the column at position 1 is equal to the column at position 2. If this condition is true, then we want to return one of these elements. So we found another 3 in a row in the form of a column, and we want to just go ahead and return that. Okay, and again, if this doesn't become true after we check all 3 columns, then we're going to complete this for loop, and we will then get here where we need to check the diagonals. Okay, and so for the diagonals, we can just have a very manual check to check these. So we can say if the board at index 0 and 0, so the very first tile, if this is not equal to null, and the board at 0, 0 is equal to the board at 1, 1. So if the top left and the middle square are the same, and the board at 1, 1 is equal to the board at 2, 2. So if the middle and the bottom right square are the same, then we've found a diagonal from the top left to the bottom right of the board. And so then we can just return whatever element is occupying that diagonal. Okay, and then we can have a similar logic for the other diagonal. So I'll just break this up a little bit. So for the other diagonal, we can actually just copy this here to make it a little bit easier. So we can start at the bottom left. So we can say if the board at position 0, and actually, so for the bottom left, it would be position 2 and 0. Sorry, the indexes are a little bit confusing to keep track of in your head. So 2 and 0 is not equal to null. And if the index at 2 and 0 is equal to the middle of the board, and the middle of the board is equal to the top right tile, then again, we can just return whatever we found, like that. Okay, and if we get all the way to here and we didn't find any 3 tiles which are the same, then that means we've checked the entire board, and there's still a little bit more logic we need to implement. So this logic here is going to basically figure out if we have a winner. But what if we don't have a winner? Well, if we don't have a winner, then there's one of 2 conditions which could be true. We could not have a winner and the game is still in progress, or the board could be completely full and we don't have a winner. And in that case, it's a tie. So there's probably several different ways you could implement this logic, but again, we can just do something very simple and straightforward, and we can just have another case here where we want to check for any tie on the board. So first we will check for the tie, and if we don't find a tie, then we want to return null. And we may be able to combine these steps. So for here, what we'll do is we'll just say for let, I'll just say for const row of board again. And then we want to go through and we want to visit at each position in the row. So we can say for const tile of row if the tile is equal to null. So if we find a null tile, then we want to just go ahead and return null. So if there's any tile which is still empty in the board, we want to just go ahead and return null because the game is not finished yet. And so this will actually be check for any, check if the game is still in progress. And if this is not true, if we get all the way through the board and we don't find any null tiles, but we also didn't find a winner, then finally here we have a tie, and then we can return tie. So else it must be a tie. Okay, so I think this logic looks pretty good. To check it, what we can do is we can come back to our debugging code down here, and next to our player class we can go ahead and just create a game class as well, and we can pass in our board, and we can use our Checkerboard method. So over here we had been playing around with this class before, and we have a human playing on this board, and we have a human filling this up here, and this should be a winning game board right here. So let's take that board and let's delete some of these other logs, and let's take the board at the end and pass it into our Checkerboard method, and we'll get some result back. And let's see what that result is. Okay, so let's run this, and you'll see the result is human. Okay, and if I remove one of the calls to play on the board, and we run the code again, you'll see that now we have null. So it looks like this is working correctly. It is telling us when we have a player winning the board with three tiles, matching tiles in a row. So that's looking pretty good. Okay, let's move on to our final method to implement, which is the play game method. So this is the method which actually executes the logic to play the game. And so the main idea here is that we want to have the two different players simply take turns playing the game until we get to a point where either there's a winner or there's a tie. So for this, what we can do is we can have a result variable, which is going to be a game result or null. And we can initialize this to be null. And then we can say while the result is equal to null, so while we haven't found a result yet, we want to let the human player play on the board. And again, our game class receives a board when it is initialized. So you can see down here, when I created a new game here, I passed in our board. So you pass in a board to initialize the game, and there's different ways you could kind of design this API, but in terms of the code here, this is how we created it to work. So you pass in a game board, and then that gets initialized on this board property of the game class. So then we have that here for us to pass into the play method on the player class. And so we're going to let the human player play, and then we're going to have the machine player play. So each player plays in their turn. So we have both players play, and then we're going to say that the result is equal to checking the board. So we then run our Checkerboard method to see if there's a winner. And remember, the Checkerboard method can also return null if the game is not finished yet. So until the game is finished, this will keep returning null, and the result will still be null until eventually we get to a state where the game is finished and we either have a winner or a tie. And once that happens, this while loop will finish because this condition will break and we'll be outside of the while loop. So then we just need to return whatever result we have here. Okay, so let's go ahead and run that code. And this passes all the tests. Okay, that's great. So this is a relatively simple project, but you can see that there is a bit of code. There's a bit of code here, and it does take a bit of work to go ahead and implement a solution which can solve the tests. So it's not that trivial to do. And I would also really encourage you to think about how you can design this game. Maybe there's completely different ways that you could design this game. Maybe you could have different classes, or maybe a single class, or the API could look different. There's a lot of different variations that you could put into this. And especially here, the logic for actually playing the game, this is where it gets really interesting. How can you design some logic which is actually intelligent, which actually can make more strategic moves? I would encourage you to think about how to design this, and then also think in terms of if you had some logic like this, which could represent a machine player, how could you design this in a way where you could actually play against that machine player? And trying to think if you could actually design a machine player which would be hard to beat. And we don't have any kind of context of entering any input in the game here. So this isn't really an interactive game. It's more like a simulation. And that's mainly because we don't really have a means of sending input into the program at this point. We haven't really learned how to do that yet. And that's coming up. That's definitely coming up later in the course, but we haven't covered it yet. So for this project, we kept it restricted to just having this more simulated game environment. But in the future, you definitely will learn these other skills to have a program where you can actually send input into it. And so I would keep this in mind for when you get to that point, because then this game can become a much more interesting project to work on, something that's interactive and more fun to actually build and play. So with that, that's going to wrap up this video, and I hope you learned something, and we'll see you in the next video.